Today we're going to look at algebra equations and functions. We're going to keep looking at expressions and equations, how we can write algebra expressions and algebra equations to describe situations. Now we're going to take the next step and we're going to call our equations functions. It's the same thing, but we're going to start making function tables and getting ourselves ready to graph algebra equations or algebra functions. So just know first of all that the term function and equations, that we're referring to the same thing. All right, but we're looking at making function tables to get ourselves ready to graph algebra equations. And if you take a look at this function table, you're going to have three parts to every function table. We have our input. That's the number that goes in. All right. You may remember from earlier grades the input-output machine. All right. That's where this was leading. This is where that was leading. We have inputs, something goes in, the machine does something to it, and then we get an output. All right. So what we start with is our input. We have some type of a function rule. What's the pattern? What's happening to the number? And then an output. Those two will be the three columns to our function table. Now, on your table, we're going to call, eventually we will graph them. We'll call the inputs our x values and our outputs our y values. We'll need that when we get ready to graph later on. For now, what you need to know is that your inputs are your domains and your outputs is your range. So we have our input, we are now going to call the domain, and the output we're going to call the range of the function table. So let's look at a couple examples and practice making function tables and labeling our domain and range. Here's one example. It says copy and complete the function table, identify the domain and range, and we'll look at how specifically to do that after we've made the function table. First of all, if you look at this table, it says our function or equation is y equals x plus 7. Right. So if you remember, we need to pick at least 3 inputs or x values. In this case, we're going to use 4, in fact, and we need to plug those numbers in for x. As we talk about in class, I'd suggest using x is 1, x is 2, x is 3 in all cases. So we'll go with x is 1. Well, if x is 1, then x plus 7 has to be 1 plus 7. And if that is indeed the case, then 1 plus 7 equals 8. So our output, or our y value, is 8. How about if x is 2? If x is 2, then the problem becomes 2 plus 7. And 2 plus 7 is 9, so my y value is 9. If x is 3, then we have 3 plus 7. 3 plus 7 is 10. So my y value this time is 10. And finally, if x is equal to 4, then the problem becomes 4 plus 7. And I have 4 plus 7 is 11, so y is 11. So now my function table is complete. I have my inputs, or x values, right here. I have my function rule, which is x plus 7. And I have my outputs, which are the y values. But the last step I have to do is identify the domain and range. And we'll take a look at how to do that. All right, to identify your domain and range, what you're going to do is you're going to write domain, the word domain, and then you'll make a bracket, which looks like a parentheses with an arrow in it. And you'll list the numbers that are the x values. Remember, the domain is your x values. So I'm going to list 1, 2, 3, and 4. And I'll close that out with another bracket. Now I need to do the same thing for the range. I have the range, and I'll label it with a bracket. And my range numbers are my y values. So I'm going to list 8, 9, 10, and 11. So there's my first function table, complete and with the domain and range labeled. Now we can also do this with multiplication. Here's an example of a function table with multiplication. This time my function is y equals 4x. So I'm going to use the inputs 2, 3, 4, and 5 and do the function 4 times x. Well, if x is 2, then the problem becomes 4 times 2. And 4 times 2 is 8. If x is 3, the problem becomes 4 times 3. And I have 4 times 3 is 12. If x is 4, I have 4 times 4, which is 16. And if x is 5, I have 4 times 5, which is 20. Next, we have to go back to domain and range. Once again, labeling domain and range. My domain, I'm going to label that with a bracket. And remember, domain is your x values. So my x's are 2, 3, 4, and 5. And my range, again, range is your y values. I have 8, 12, 16, and 20. There's a function table using multiplication. You can make a function table using any operation, as long as you have the algebra equation. The last one we'll look at is one that actually involves decimals here. You can see I have the equation y equals x minus 5/10. So if I do this problem, I'm going to, once again, put in my inputs. X is 1, 2, 3, and 4. So if x is 1, the problem becomes 1 minus 0.5. And 1 minus 0.5 is 0.5, or a half. If x is 2, the problem becomes 2 minus 1/2, which is 1 and a half. If x is 3, I have 3 minus a half, which is 2 and a half, or 2 5/10, however you prefer to say that. And finally, if x is 4, you have 4 minus 5/10, which is 3 5/10. Now I have my inputs, I have my functions all completed, and I have my outputs. So I'll label the domain and range. My domain, again, reminder one more time, domain is your x values, your inputs, and I inputted 1, 2, 3, and 4. My range is my outputs, which is 5/10, 1 5/10, 2 5/10, and 3 5/10. And we'll close that off with a bracket. And there are a few examples of how to create a function table given the function. The last thing I want to look at is a word problem where you're not given the function. You won't always be given. If you're given the function, like we were in each of these tables, then it's plug the numbers in and find your outputs. But how about a situation where you're not given the function? You have to find it. Here's an example. It says for every row of corn in Mr. Jones's garden has 5 corn stalks. Every row of corn has 5 corn stalks. What we need to do is write an equation using 2 variables to show the relationship between the number of rows and the number of corn stalks. So I'm going to make a function table here, just a quick sketch of a function table. And I'm going to make a column for my x's, and a column for my y's, and a column for my function rule. All right, so I'm going to choose if I have 1 row, 2 rows, or 3 rows. And again, if I go back to the situation, it says every row of corn has 5 corn stalks. So if I have one input of 1, if I have one row, I have 5 corn stalks. If I have 2 rows, I have 10 corn stalks. And if I have 3 rows, I have 15 corn stalks. So I have to look at how did I decide that? I could say I skip counted by 5s, 5, 10, 15. But again, we want to start looking at it algebraically. We want to start looking for how did I get from my input to my output? Well, if I look in each case, 1 times 5 is 5, 2 times 5 is 10, and 3 times 5 is 15. So what I'm doing is taking my x value, my input, and multiplying by 5. So I'm going to say my function rule is 5 times x. So that becomes my function rule, or my equation. Y equals 5 times x. Now I can use that to answer the question below. It says, if Mr. Jones has 7 rows of corn, how many corn stalks will he need to harvest? Well, I could skip count by 5s until I get to 7, or I could simply say my equation is y equals 5 times x. I want to know if x is 7. If x is 7, what's my output? And I know that 5 times 7 equals 35. So I can say that 7 rows of corn will have 35 corn stalks. So keep in mind, it won't always be just, here's a function table, fill it in, and identify the domain and range. Sometimes you need to make your own table, look for the pattern, and write your own function. In either case, we're looking for the inputs and outputs, your domain and range, to make a function rule, and this will have us ready when we take the next step to look at graphing these points to make graphs of our algebra equations.